So how did you, 7 for x? No, 7 was a part of the probability function. So remember, this was our function, you know. Remember, this was our function where f of x is equal to 7 minus x divided by 10. So 7 was a part of our function. All right. Alright, so it says according to a study by a road safety interest group, the probability that speeding is a cause of a fatal crash is 0.3. Furthermore, the probability that speeding and missing a curve are the causes of a fatal crash is 0.12. Given that speeding is of crash, what is the probability that the crash occurred on a curve? So first of all, what are we dealing with? This is asking us for a conditional probability. But before we jump to that, we need to define our terms. So write down what we were given. So we're going to let the probability that S be the probability that speeding is a cause of a. Then we're going to say let the probability of M be the probability that missing a curve that missing a curve is the cause of a fatal crash. Then we're going to say let P of C be the probability that a crash occurred on a curve. So we have 3 different events where we have probability that speeding is a cause of a fatal crash, the probability that missing a curve is a cause of a fatal crash, and the probability that the crash occurred on a curve. So in order to solve this question, we made an assumption that speeding, missing a curve, and crash occurred on a curve are independent of each other. Because if the crash occurred on a curve, you did not miss the curve, so the probability of M and C would be independent of each other, and one speed and have a fatal crash, but it is not caused by hitting a curve. So each event, we assume that each event is independent of each other. So remember, I told you that the sum of probabilities must be equal to 1. And we can say, based on the question, that the probability that a crash occurred on a curve is a complement of missing the curve, and it causes a fatal crash. So in order to find the probability of a crash occurring on a curve, we're going to say like the probability of C equal to 1 minus the probability of S. Now we're going to write down what we know. So we know that the probability of speeding is a cause of a fatal crash is 0.3, and the probability that speeding and missing a curve are the cause of a fatal crash is 0.1. And because they said and, we know that we're dealing with an intersection between the probability of S and M. So now, in order, we need to find C. Because remember that the question that we're given is that given that speeding is the cause of a crash, what is the probability that a crash occurred on a curve? So in order to find the probability of C, we need to solve for M, the probability of M. So we know that the probability of having a fatal crash caused by speed and having a fatal crash caused by missing a curve is independent of each other. So we can say that the probability of S times the probability of M. But remember that we're trying to solve for M. So in order to solve for M, what we can do, since we have the probability of S and the probability of S intersect M, what we can do is divide both sides by the probability of S in order for us to get the probability of M. So the probability of M is going to be equal to the probability of S intersect M divided by the probability of S. Again, all you have to do now is to substitute your values into the equation. So know that the probability of S intersect M is equal to 0.1 and the probability of S is equal to 0.3. So 0.1 divided by 0.3 is equal to 0.4. Again, if you guys have any question, please raise the question. So now, since the probability of M, we found the probability of M, we need to find the probability of C. So since the probability of C is equal to 1 minus the probability of M, it's going to be, so probability of C is going to be 1 minus 0.4, which is equal to 0.6. Remember that our question was, given that speeding is the cause of crash, what is the probability that the crash occurred on a curve? So now we write our probability statement. So the probability that given that speeding is the cause of crash, what is the probability that the crash occurred on a curve? So this is going to be our probability statement, which is our conditional statement, probability statement. And we know it's going to be equal to the probability of C intersect X divided by the probability of S, since S is a value that comes after or given. So the only way that C can happen is if you're speeding. That's what the question is saying. We weren't given the probability of C intersect S, so we know we have to solve for it, which is going to be, remember that these events are independent of each other. So the probability of C intersect S is going to be the probability of C times the probability of S. This is supposed to be S. So this is supposed to be the probability of S divided by the probability of S, which is going to be equal to 0.6 times 0.3 divided by 0.3. We can cancel both our 0.3 and we're going to be left with 0.6. So the probability is therefore going to be, so given that the speed is the cause of crash, what is the probability that the crash occurred on a curve? The probability is going to be 0.6. Do you guys have any questions about that?
Yeah. Yeah, I answered.
Or did I explain it good enough for you? Hey guys, do you guys have any questions about that question, or was it explained in detail for you? How did I get the 0.6? All right, so for the 0.6, it's all listed. Remember that I told you that. Remember that the sum of all your probabilities must be equal to 1. In this case, the probability of M is the probability that missing a curve is the cause of a fatal crash, while the probability of C is probability that the crash occurred on a curve. So in order to find C, the probability of C, the complement of C would be the probability of M. And to find the complement of anything is normally 1 minus whatever the complement is. So in order to find the probability of C is equal to 1 minus the probability of M. We were given the probability of S, 0.3, and the probability of S intersect M, which is 0.12. Follow me. So in order to find P of C, we need to solve for P of M. Because we don't know what the probability of M is, we don't know what the probability of C is. But we have values that can lead us to that. So the probability of S on M was 0.12. But remember, we made the statement that S, M, and C are independent of each other. Of S, the probability of M, and the probability of C are independent of each other. And remember that when something is independent of each other, we multiply them. So the probability of S intersect M is equal to the probability of S times the probability of M. We are solving for M. So in order to solve for M, we need to divide both sides by the probability of S. And we get this. So the probability of M is going to be the probability of S intersect M divided by the probability of S, which is going to be 0.12 divided by 0.3, which is equal to 0.4. Where the 0.6 came from was that since the probability of C is equal to 1 minus probability of M, and remember that we just found out that the probability of M is equal to 0.4, so 1 minus 0.4 is going to be equal to 0.6. The question that was put before us, or they posed, was that given that speeding is a cause of crash, what is the probability that the crash occurred on a curve? So we know we're dealing with a conditional probability statement. So what is the probability? So given that speeding, remember that whatever, so given that speeding is the cause of the crash, what is the probability that it happened on a curve? So that's the first thing you need to do, is write a probability statement. And remember that the only way the crash occurred on the curve in this statement is because the person was speeding. So now we can rewrite our formula for a conditional statement as probability that C intersect S divided by the probability of S. As I said before, this is an error, so this should be the probability of S. The denominator should be the probability of S. But remember that we don't know what the probability of C intersect S is. But we know that they're independent of each other, and based on independence, we know the probability of C intersect S is going to be probability of C times the probability of S. And we know the probability of C is 0.6 based on what we calculated up here, times the probability of S we were given, which is 0.3, divided by the probability of S, which is 0.3. All you have to do is cancel this, and we're left with 0.